All right, welcome back. So, whenever we talk about, we continue for Android earlier, right? Well, you have the ability to basically build and put your own operating system. Actually, an operating system generally is designed to run on a class of system with variety of peripherals, right? Now, commonly an operating system is already installed and installed on the purchased computer, but you can actually do this on your own, right? You might not want to do it for most cases, because it's such a headache, but it is possible, right? So you can basically build and install some other operating system on your machine, right? For example, in Linux, right? If generating an operating system, if you're generating an operating system from scratch, basically we have to write the operating system source code, right? If you want to try this, you don't have to write one. You can just take the operating system on a Linux kernel platform, right? Then you would configure the operating system for the system on which it will run, right? So, which means if you're running it on a Intel uh, 686, then you would compile it and configure it to run on the 686 and compile the operating system, right? Then you would install the operating system itself, right? So you have to compile it according to the computer architecture and then compile it and install the operating system, right? Boot the computer in its new operating system, right? So it doesn't mean that one computer is built on a particular machine, then that's going to be the only operating system that can run on it, right? In fact, you can, if you configure the operating system according to the computer architecture, right? According to the system, then you can basically put any OS in any machine, right? Of course, assuming that you can configure those things, right? Now, Linux actually has a support for many different kind of systems, right? So we would download the Linux source code, configure the kernel using the make menu config. So we configure it and choose the kind of hardware that exists on it. The Intel platform, the i3 686 or whatever hardware that you have. And after you compile using the make command, it will produce a kernel image, right? So this is basically the kernel image on a Linux system, right? Now the kernel will also need to run all the other modules that would work with the kernel. So you would also need to compile the modules along with it, right? So then you would install the kernel modules via make modules install and install the new kernel on the system via another command called make install, right? So now, after you would have all of this, you would have to configure the system boot, right? So now you have a kernel, you have the modules that would run on the kernel, but then you would require, when you boot up the system, you would need it to tell where to execute uh, this kernel, right? So you basically to execute this kernel at a specific location, right? The operating system must be made available to the hardware, so hardware can basically start the particular system, right? So usually we'll be using a small piece of code called a bootstrap loader, a BIOS that is, usually this is basically stored in the BIOS, stored in ROM or EEPROM that locates the kernel and loads it into memory and starts it, right? What this process do basically is a two-step process where the boot block at a fixed location loads the ROM code, right, which load the bootstrap loader from the disk, right? So software itself in the disk, but the bootloader basically finds this, right? In modern operating system, we have something that's called the unified extensible firmware interface, or some people call it uh, UFI, right? Now, this actually kind of abstract this in trying to find the boot block at the fixed location, right? Now the common bootloader bootstrap loader is called grub, which allows the selection of kernel from multiple disk versions and load the kernel options, right? And after this, the kernel will load and the system is then running with your new operating system with the kernel that you just compiled, right? Now there's some other things that you can enable with debugging or performance tuning. All of this is also capable of being done on your machine, right? Whenever the system fails, it will basically throw a core dump or a crash dump that you can analyze to see what went wrong, right? There are a couple of things that you can do for performance tuning. In Linux, we use stops. In Windows, we use Windows Task Manager to see what kind of performance you get, CPU, memory-wise, disk-wise, etc. There's several trace application that you can trace what's wrong with the source code, system calls, performance tools, and TCP collection of network packets. Okay, so I'm gonna skip some of these things. They were at the end of the chapter. This is the whole stack of the Linux tracing tools, but do explore it on your own and Google about it. All right, so I'll see you in chapter 3, and we're looking forward to see you again in a different session of this video presentation slides. See you. Bye bye.